Hello Pre-Algebra students, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Surface Area of Prisms and Cylinders. Let's take a look at this. The surface area of a prism refers to the sum of all the areas of all the faces. The sum of the areas of all the faces of a prism. Now, what does that really mean? I'm going to show you something that is actually not on your guided notes. Something I used to teach in 7th grade many years ago. And it's the idea of taking a three-dimensional shape, such as a triangular prism, and basically cutting it out so that way it's just all the faces that make up that triangular prism. It's officially called the net of the triangular prism. And what you will notice is that, as you would expect with a prism, there are two triangles, parallel and congruent to each other. But then there's all these rectangles. So what surface area does is that it finds the area of the triangle, takes it times 2, and then finds the area of these rectangles, adds it to the area of the two triangles, and that gives you the surface area. Now, there's a much more efficient way of getting that, which will use a formula that Pennsylvania has on their formula sheet. We'll get to that very soon. Now, back to the guided notes. Next part of your guided notes, identifying the prism's bases and heights. I had this same exact section on the volume of prisms guided notes. Take a look at this. Bases are not always at the top and the bottom. They could be in the front and in the back. Same thing with trapezoidal prisms. They don't always have to be on the top and the bottom. They could be in the front and the back. So please remember that. And please remember that the height is always the line segment that goes between the bases. No matter if the bases are the front or the back, the height will still be the line segment that goes in between. All right, now let's talk about this formula that Pennsylvania provides that will work for any polygonal prism. Not just triangular prisms, but also pentagonal prisms, trapezoidal prisms, and so on. As you learned from the volume formula of polygonal prisms, capital B is the area of the prism's base. Well, we also need capital P for the perimeter of the prism's base. And then we already said H is that measurement that goes in between from the one base to the other. Using those ideas, they have this formula, they as in Pennsylvania, for the perimeter of the base times the height plus 2 times the area of the base. Because remember, we talked about how there's going to be 2 of those bases parallel and congruent to each other. This is why we have to have 2 times capital B. All right, here's an example I've created for you. I think I gave you this exact same example on the volume guided notes, but this one is going to be finding surface area. So we need the perimeter of the base and we need the area of the base. So as I recommended on the volume guided notes, draw a quick sketch of the triangular base. And not only do we need the height and the base to get the lowercase b and the lowercase h for the area of the triangle, but we also need the other measurements for the perimeter of the triangle. Remember, the perimeter would use all of the exterior sides of the triangle. So that's not going to include the 7.8. 7.8 is the height. That's not an actual side of the triangle, but it will use the 9, which you can see here. It will use the bottom, the 12.25, and it'll use the right edge as well, which was the 11. So I have all these marked here, and we're going to add those measurements together because you do not need a formula for perimeter. Just add the 3 exterior sides of the triangle to get the perimeter of the triangle. Now, if it was a trapezoid, you would have 4 exterior sides. If it was a pentagon, you'd have 5 exterior sides. You guys know how that works. So that's how you get perimeter. Once you have the perimeter of the base and you have the area of the base, now you can substitute those things in for capital P and in for capital B. No big deal. But what about lowercase h? This h is not the same as the h we had up here. It is referring to the line segment that goes between the two bases. So that, in this example, is the 15. So we substitute that in as well. Formula substitute solve. We get our surface area. Now, this second to last step where I wrote the 483.75 and the 95.55, you don't necessarily need to show that step. I know you can probably enter the entire thing into your calculator and it'll follow the order of operations for you. Most calculators will. You should test this out on your own. Make sure you know whether your calculator follows order of operations or not, because if it doesn't, then you would need to show this step right here. Okay, rectangular prisms have their own surface area formula. 2 times length times width plus 2 times length times height plus 2 times width times height. That even though it's longer, is a lot quicker to use than doing the method that we did here with the triangular prism or trapezoidal prism, because that requires perimeter of the base and area of the base, and then putting those things back into the surface area formula. Rectangular prisms, much quicker to just use this unique formula for just the rectangular prism surface area. Note, a cube where all sides are the same measure has the easiest surface area formula of them all. You just take s to the second power, which gives you the area of one of the squares, take it times 6 because there's 6 sides to a cube, and boom, you have your surface area of a cube really nice and easy. Here's a quick example of the surface area of a rectangle. You can see I'm just substituting these numbers in, really not that big of a deal. It does not matter which number you call the L, the W, the H. However, you might want to actually label it on the drawings so that way you don't lose track of what numbers are going where, because I've seen kids do that, where they totally lose track of what numbers they're using here. So you might want to actually on the drawings label it L, label it W, label it H, and that way you'll know what numbers go where. Again, the second to last step might not be necessary. A lot of calculators will follow the order of operations for you. If your calculator doesn't, then yes, you'll have to do each of the multiplication pieces separate and then add at the end. That's order of operations. Okay, I believe on the next page, let's talk about surface area of a cylinder. It's almost an identical formula to the surface area of a triangular prism or trapezoidal prism, generically called a polygonal prism. However, you wouldn't use P anymore for perimeter because the distance around a circle would be called the circumference. So instead of perimeter of the base, we need circumference of the base. Now we'll still use area of the base. That's still going to be there. So instead of PH plus 2B, it's CH plus 2B, and that will give you the area of the cylinder, surface area of the cylinder. So pretty self-explanatory. The only thing you got to watch out for, make sure you actually have the radius. Some drawings will give you the radius right away. No big deal, like this one did. Other ones might give you diameter. If that's the case, you'll have to divide it by 2. I would keep the circumference and the area, I'd keep it in terms of pi. I would not get the ugly long decimals that you're tempted around to the nearest tenth. Don't do that yet. Keep them in terms of pi, so that way you will have an exact as you can get, surface area answer. Again, this step right here might not need it. Most calculators follow order of operations. I've already talked about at length on this video. So you have to decide for yourself whether you need that second to last step or not, depending on how well your calculator follows order of operations. Surface area, I should note, is not cubic inches or cubic feet or cubic meters. It's square inches because it's surface area. So keep that in mind. Okay, time for you to try some problems on your own. Problem number 1 is a trapezoidal prism. I will give you that because the base is 2 parallel congruent trapezoids, so you're going to want to keep that in mind for problem number 1. So try number 1, try number 2, try number 3, and also number 4 on your own, and then we'll see how you did. So hit pause now, do 1 through 4, then hit play when you're ready to see how you did. All right, I will admit, I bet there's probably at least one kid who's like, I don't even know where to start. Okay, so if that's you, I'll give you a jump start on number 1, and then you can finish it on your own. The jump start is draw a sketch of the base and label the sides. You're like, well, isn't that all these numbers here? Well, no. The 7 feet is this line segment that goes between the trapezoids, so we're not going to use that when you label the sides of the actual trapezoid. So label those sides. We got 29 feet, we got 22 feet down here, and then the left side meeting at the right angles is 24, and this diagonal side is 25. Now you can find the perimeter of that trapezoid and then the area of that trapezoid, and then eventually substitute it into the surface area formula. So there's your jump start for those of you who needed it. Hit pause if you haven't finished this yet on your own, and also done 2, 3, and 4. If you already did them, then let's go ahead and continue on. Again, make sure you hit pause if you didn't already do this on your own. All right, perimeter of the trapezoid. All you have to do is add the four sides of the trapezoid together. Not that big of a deal. You get a nice round answer of 100. Not that that's normal, but this one did. And then let's talk about the area of the trapezoid. It's this kind of long area formula from your formula sheet. Which numbers do we actually need? Well, the height, you know what, let's start with this. The bases are the two sides that are parallel. So that's the 22 and the 29. They're parallel. The height is what touches those bases at a right angle. So that would be the 24. So formula substitute solve. Here's your substitution. You're going to get an area of 612 square feet. Now we can substitute those answers, the perimeter and the area, in for capital P and in for capital B. However, don't forget who the H is. It is the line segment that goes between the trapezoid. So that little tiny line segment goes in between. That is what we call the H. I know it doesn't look like height, but that's because the trapezoids were in the front and the back instead of being at the top and the bottom. So there's your substitution into the formula. Again, the second to last step might not be needed if your calculator follows order of operations very nicely. 1,924 square feet is your answer. All right, moving on. Problem number 2. If you didn't do this yet, you better hit pause. Do it now. But otherwise, here we go. The triangle, hopefully you drew a quick sketch, labeled the sides. That's 6, that's 8. And this diagonal is actually given to you over here. So that is the 10. Now we can find the perimeter of that triangle and the area of the triangle using the area formula of triangles from our formula sheet. All right, perimeter of the triangle, add the 3 sides. Notice we're not adding the 12.5 because that is not actually on the triangle. 6 plus 8 plus 10 gives you a perimeter of 24. And then, did you use the correct sides for base and height? We always look for the right angle. The base and the height are the numbers that meet at that right angle. So 8 and 6, not the 10. So that's going to give you, ironically, also 24. Pure coincidence that they both ended up being the same number. That's actually not normal, but it happened here. All right, surface area. Now we have to be able to put the numbers into the proper places. Looking back at the original drawing, the 12.5 is the line segment that goes between the triangles. So that's that thing we call the H in our surface area formula. All right, multiply, add. Again, the second to last step might not be needed. Final answer, 348 square feet. If you have to hit pause to fix your work, hey, hit pause, fix your work if you need to. Otherwise, moving on, problem number 3. This is a cylinder, except the circles in the front and in the back. You can't really see the one in the back, but it's definitely there. And we need to get the circumference of the base and the area of the base as well. But watch out. This 24 yards is not the radius. The radius would only go from the center to the edge. So this is the diameter. Divide that by 2, and you will get the radius of 12. So check your work. Did you use 12 as the radius? 2 times pi times 12 is 24 pi. Notice I didn't even take it times pi in my calculator and get the ugly decimal. 2 times 12 is 24, so 24 pi. Keep it in terms of pi. Over here, 12 to the second, 144. Again, keep the pi. Now you can substitute it into the, almost like the polygonal prism surface area formula, but it's the cylinder surface area formula. Circumference times h. The h is the 27 because it's the line segment that goes between the circle in the front and the circle in the back. So 27 is your h. 24 pi, 144 pi. Don't lose the 2 here. Now, I actually like to go ahead and write this as, again, in terms of pi. 648 pi, 288 pi. Final answer is 2,940.5 square yards when you round to the nearest tenth. Did the directions say to do that? I can't remember if they did or not. All right, problem number 4. If you accidentally use the polygonal prism surface area formula, I'm not going to lie, it could work theoretically, and I've seen kids make it work, but I'm telling you, I find this to be a lot easier. So if you need to hit pause and redo number 4, hey, feel free, do what you got to do, okay? This video is for you, not for me. All right, from here, I like to go ahead and make a decision. of what I'm going to call what. So what I did is this. I decided that I was going to call the length the 10 yards. And then I called the width the 7. And then I called the 12 the height. Did you have to do it that way? No. Maybe you called the 7 the length and the width the 10. I don't know. Maybe you called the 12 the length. Who knows? You therefore might not have the numbers in the same order as me. But somewhere you should have a 2 times 10 times 7. Somewhere you should have a 2 times 10 times 12. And then somewhere you should have the 2 times 7 times 12. Check to make sure you had those 3 parts in your work. If you went ahead and multiply before you added, these are the 3 products you get before you add. Final answer is 548 square yards. Okay, let's talk about problem solving using surface area. It's important to know, especially before we take our test, when does a problem require volume to solve versus when it requires surface area? Well, it's actually really simple when you think about it. Volume is filling up the 3D shape, and you could be filling it up with maybe water in real life, maybe you're filling it up with sand, maybe you're filling it up with packing peanuts, I'm thinking of like shipping Amazon or something. Whatever. That's what volume is, filling up the 3D shape. Surface area is covering the sides of the 3D shape. Now, examples could be wrapping paper, like wrapping a box, or maybe painting a 3-dimensional figure, so all the outside faces are being painted. Those are ideas of surface area. All right, so there is a special scenario I want to mention real quick. What do you do if you need to find surface area, but not every side is fully covered? Now, I know this is probably not a scenario that happens a lot in life, but it could. You could maybe have a box where the top is open, therefore you don't need the rectangle at the top of the box. So that's kind of an example. So here's what I would recommend doing. Here's my answer. Find the full surface area first using the formulas that I've been showing you. But then, what area of the part that's not being covered, find that area and subtract it away from the full surface area. That's probably the easiest way of doing this special scenario. Okay, speaking of special scenarios, take a look at number 5. Jason wants to paint a cube with red paint except for a section that will have a triangular logo as shown in the picture below. How many square feet of paint will he need to use, assuming he uses just 1 coat of paint? So you can see this triangle is not getting the red paint. It's not. I think on your guided notes, this probably looks gray instead of red, but I have it here in color. So what I recommend doing, find the surface area of the entire cube. Oh yes, may I point out, cube has its own surface area formula, spoiler alert, and then I would find the area of the triangle. Then, after you have the area of the triangle and the surface area of the cube, subtract them and that will give you the surface area that's actually getting red paint. So, try number 5 on your own, now that I've kind of given you a little bit of a hint as to how to start it. And then I would also like for you to read number 6 and try that one on your own. So, time once again. Hit pause in the video, do number 5, do number 6, then once you're done, then hit play to see how you did. All right, did you already do number 5 and number 6? If not, hit pause now. It's important to be practicing this on your own. All right, surface area is really nice with the cube. Take 8 to the second power, which is 64. Take that times 6, and you get a surface area of 384 square feet. Now, that's not the final answer. We need to get rid of the triangle because that's not getting painted red. What's the base of the triangle? Well, normally base is at the bottom, and this is kind of upside down. So the base is definitely the 8. I mean, every side here of the cube was 8. But what about the height? Well, that's actually going to also be 8. The height of the cube would be the height of the triangle, so that's actually quite convenient. So, formula substitute solve, the area of the triangle that's not getting painted red is 32 square feet. So what I would then do, subtract 32 from 384, and you get the amount of paint will be 352 square feet of red paint. All right, finally, problem number 6. Marvin buys a gift, places it in a box shown below, to be given to a family member. The gift costs $24.99 plus 6% sales tax, kind of like Pennsylvania. If he chooses to have a gift wrapped at the store too, and it costs 2 cents per square inch to do that, how much total money will he need to spend for this gift? All right, this is definitely a multi-part problem. Key idea, it's being gift wrapped, so that means we're talking surface area, not volume. We're not filling up the box. We are wrapping it around all of the faces of the box, so that is surface area. I would recommend using the surface area formula of a rectangular prism. And again, I would make a decision on who I call length. I call 12 my length. Who I call the width, I called 4 my width. And then I called the 3.5 the height. You could have it switched around. So check your work. Somewhere you should have 2 times 12 times 4. Somewhere you should have 2 times 12 times 3.5. And somewhere you should have 2 times 4 times 3.5. From here, that's going to give you a surface area of 208 square inches. But we're not done. We need to realize that the gift costs $24.99, but there's also 6% sales tax, but we're also getting a gift wrap for 2 cents per square inch. So let's take the cost per square inch times the square inches, which is 416. But don't forget, we also have to pay for the gift, which was $24.99. That's going to give you $29.15. Are we done? No. Apparently they're buying this in a state like Pennsylvania that has 6% sales tax. So if it's 6% sales tax, that means the original price is up, which is 100% of itself, $29.15, is now going to be increased by 6%. That means you're paying 106%. So the quickest way of doing this is to multiply by 1.06. Now, there is another way. Some of you might have just multiplied by 0.06, got that answer, and then added it back on to the 29.15. That would also work. I just find this to be a little bit quicker. So, final answer. Now, I did have to round to the nearest cent because dollars and cents, 2 digits after the decimal point. $30.90. Done. All right, thank you for watching this video. We'll see you next time.